Hello friends. Situations sometimes occur in electrical engineering in which it is desirable to find particular branch current in a network as resistance of that branch is varied while all other resistance and source remain constant. For handle such type of situation, Thevenin's theorem is used. So let us understand the Thevenin's theorem with some examples. First example. Desire the determine the current through the emitter of resistance 2 ohm connected in western bridge of figure. Here 2 ohm is here, this is an emitter. Hence we have to find the current through this branch. For that, first of all remove the emitter from the network as we have shown a figure A here. Now we will determine Thevenin equivalent voltage. For that, potential of A with respect to D, which will be equal to 12 multiplied by 4 divided by 6 is equal to 8 volt. Here 6 represents 4 plus 2. Now potential of B with respect to D, which will be equal to 12 multiplied by 6 divided by 8. Now what here 8 is suggest? 8 suggests stand for 6 ohm plus 2 ohm in series combination. Therefore, Thevenin equivalent voltage will be equal to VB minus VA, which will be equal to 9 minus 8, which will be equal to 1 volt. With B with positive. Here B is positive. Because as we have considered 9 minus 8 because potential of B is higher than potential of A. Now we will determine Thevenin equivalent impedance, that is resistance or impedance. For that, replace the source. Source is here 12 volt, that will be replaced by short circuit, which is C and D is short circuited, and after redrawing that network we will get this circuit. For that, to determine the Thevenin equivalent resistance, that will be equal. Okay. Here 4 and 2 are in parallel combination, while 2 and 6 are in parallel combination. Hence 2 multiplied by 4 divided by 2 plus 4 plus 2 multiplied by 6 divided by 2 plus 6, 2 into 4 8 divided by 2 plus 4 6 plus 6 into 2 12 divided by 8, which will be nearly equal to 2.83. Unit is ohm. Now we have drawn here a Thevenin equivalent circuit. Here values RTH given, VTH we have determined earlier, and 2 ohm resistance was connected at here in a given network, which is shown here. Now the current flowing through that branch can be simply calculated by equation VTH upon ZTH plus RL. Here what RL? RL is load resistance 2, which will be equal to 1 upon 2.83 plus 2, which will be equal to 1 upon 4.83, that will be equal to 0.21 ampere. Hence this is the current which will flow through a 2 ohm emitter resistor, 2 ohm resistors, which is an emitter. Now another example to understand Thevenin theorem, that is find the current in 10 ohm resistance in the network of figure using Thevenin theorem. Here some resistance are connected and one battery or DC supply is given. Now first of all what we will do a delta connected system converted into star connection. Now how it will be done? It will be done through like this. Here 3 terminal, one terminal, second terminal and third terminal. The 3 terminal will be converted in equivalent to these 3 terminal. Now how it will be converted to this? Here sum of 8 plus 4 is equal to 12. Now across this 12, across this 12 ohm, across this 12 ohm. As per conversion of delta into star, it will be divided by 3, because here all branch resistors are same, that is 12 ohm, and 12 divided by 3, which will be equal to 4 ohm, which we have right earlier. Now 34 ohm and 10 ohm will be remain as it is. Here this also same thing, that is 30 ohm across this, 30 ohm across this, and here will be 13 plus 17, which will be equal to 30 ohm. Hence, after converting this into star connection and then finding an equivalent resistance by dividing by 3, because here also resistance are same, 30 ohm, 30 ohm and total 30 ohm. 30 divided by 3 is equal to 10 ohm, which will be here 10 ohm, 10 ohm and 10 ohm. This is a star delta conversion. To understand in detail the star delta conversion, we will upload a next video later on. Now this connect the 10 ohm resistance across which we have to find current. Here is the 10 ohm resistance. So as in figure we have removed that 10 ohm resistance. Now we will find the Thevenin equivalent voltage, that will be equal to VCD. It means voltage across terminal C and D. That will be equal to 4 plus 34 plus 10 multiplied by 180. That is a potential difference, divided by total resistance 4 plus 4 plus 34 plus 10 plus 10. That will be equal to 48 total, multiplied by 180 divided by 62. Hence equivalent voltage, Thevenin voltage will be equal to 35 volt. Hence this is a Thevenin voltage. Now we will determine the Thevenin equivalent resistance for this network. For that we have drawn a network containing two open terminals, that is A and B. We have just simply redrawn this circuit by short circuiting the voltage source. Okay. Now Thevenin equivalent resistance will be equal to ZT, will be 4 plus 10, that is these two resistance, plus 34, 4 and 10. 34 plus 4 plus 10, that is in parallel with 4 and 10, parallel with 4 plus 10. Now this will be equal to 14 plus total is 48 and parallel with 14, which will be equal to 14 plus 48 multiplied by 14 divided by 48 plus 14. Now just by simply solving this we will get 24.84 ohm. This is a Thevenin equivalent resistance. Now Thevenin equivalent network will be is shown here. We have already calculated Thevenin equivalent voltage, that is 139.35 volt. Thevenin resistance, that is 24.84 ohm. Load resistance is already given as a 10 ohm. Hence the current through the load resistance will be equal to Thevenin voltage divided by Thevenin resistance, that is ZTH plus RL, which is equal to 139.35 divided by 24.84 plus 10, that will be equal to 3.9997 something ampere, which will be nearly equal to 4 ampere. Hence we can determine the current in any branch through a Thevenin theorem while the resistance may be varied. Here load resistance RL can be varied for further calculation, and we can just simply change here the value and we can get directly current. Hence this theorem is useful to find current through branch which contain varied resistance. Thank you for watching. If you like this video, please share and subscribe to our channel.